How do logic gates work? What are logic gates? How are they made? Well, today I'm going to be showing you why logic gates are so unknown. Even though they are in all electrical devices and use the number system, binary, to process mathematical questions. Join my Patreon to download my digital logic sim projects and one-to-one learning. The link is in the description. Binary is a number system using only zeros and ones. Our number system uses 10 digits, 0, 1, 2 and so on until 9, and then there isn't a number after that, so you add 1 to the next place. Binary goes like 0, 1, but then there aren't any other numbers after that, so it adds 1 to the next place. 10, 11, 100, 100, 1. Each place is 2 times the original because it's a 2-digit number system. Each place goes 10 times in the 10-digit number system. Why does a computer use binary? Well, the main reason is because a wire with current can either be on or off, 1 or 0. So I've bought this breadboard and some components that I'll use to demonstrate what I'm explaining. This circuit turns this LED on when powered. This is a basic circuit. If you want me to explain all the circuits I show in this video, I will make a second video explaining how to make circuits. So, what is a logic gate? First we need to look at transistors, which are the basic building blocks for more complex circuits that involve logic, using binary to solve multiple problems. Another way transistors can be used for is making all the different logic gates. I'm not going over all of them in this video, but I have made a video about them before. In the top right corner there should be a link. Click on that if you don't know all the different logic gates, and then come back to this video. So, how do you add in binary? Well, it's the same as normal adding, except when it reaches 1 plus 1, which is 10 because the next place is 2. The same with 101, which is 5, and 001, which is 1. When added together, the 1 goes in the 1's place when added, carries into the 2's place, and outputs the final answer, which is 110. That's 6 in binary. Subtracting is the same, except we're taking away. So, 010 minus 001 equals 001. So, 111, which is 7, minus 010, which is 2. It takes 1 from the first input and outputs the final answer, which is 101. That's 5 in binary. The main two logic gates used in Sebastian's digital logic simulator is the AND gate and the NOT gate. To show how logic gates work depending on the input, we need a truth table. A truth table shows the inputs and the outputs, and all the different combinations of inputs, and what the logic gate outputs depending on the inputs. A NOT gate truth table can be shown like this: the input, the output, and all the different combinations of inputs. So when the input is 0, the output is 1, and when the input is 1, the output is 0. The inputs count up in binary. A AND gate truth table has 2 inputs, 1 output, and all the different combinations of inputs, counting up in binary: 0, 1, 2, and 3. Only when both inputs are 1, the output is 1, else is 0. Here is a NOT gate made out of transistors. I have also made the AND gate out of transistors. Here. I will be explaining how to make these circuits in a separate video. You may have noticed these resistors. They are one of the main building blocks in computers, and if you look carefully, you can see some in a PC. Resistors slow down the current through the wire, therefore when an LED is attached to the resistor, the light is dimmer than before. So, how do computers use logic gates to turn code into a game? Well, that's for another video. Hope you enjoyed this video. Make sure you subscribe and join my Patreon for one-to-one learning and more. Also, join my Discord server to chat to people who know more advanced than me and can help you in stuff you don't yet understand. Click my latest video or watch how I made a programmable computer